Good morning to everyone. I am Professor S.Gopalakrishnan, Assistant Professor in the Department of Master of Computer Application, SNS College of Technology, Coimbatore. In this session, I am going to discuss about linear data structure. The previous session we have discussed what is data structure, the definition of data structure, what are the types of data structure we have discussed. In this session, one classification is called linear data structure. This session we are going to discuss about the linear data structure. The linear data structure is defined as the linear data structure. The data can be linear. User can make modifications among the existing data which are stored in a data structure. Data structure is existingly. The example of linear data structure are stack and queue. So now we are going to discuss about stack. Stack is a collection of data which are stored in a continuous memory location. It is also a kind of array, but this particular array is single-ended array. So single-ended array means we are using a same end to insertion and deleting the data from that particular data structure. Whether we are doing insertion operation into that particular stack and deletion operation from the particular stack is doing with the same end, which is simply called as top. For example, we are defining the size of the particular array, that stack. It means, for example, we are going to enter 5. So 5 element we can enter into that particular stack. So in that, the element which is inserted into the stack at first, that can be placed in a position of last at the stack. So the next element is the next top position. The next element is the next top position. Like that, all the 5 elements have inserted into the stack. The operation of inserting the element into the stack is called push. So when we are reaching the level of the stack size, by the time the stack is becoming a condition of stack full. So after that, the user is unknowingly trying to insert more than the limit. By the time the stack is becoming the condition of overflow. So when we are deleting the element, by the time the stack is following the principle of last in first out method. The last in first out method in the sense, the element which is inserted into the stack at last, that can be removed from the stack at first. So this reason, the stack is following the principle of last in first out method. Why? Because the element which is inserted into the stack at last, that is placed in the topmost position of a stack. While we are removing the stack, we are using a single end for deleting the element also. So the element which is placed in the topmost position, that can be removed first. Then after that, the next element, in such a way we are removing the element. The removing the element from the stack is simply called as pop. So once we popping all the elements, all the 5 elements from the stack is come to the condition of stack empty. So unknowingly user is trying to popping the element from the empty stack. By the time the stack is going to stack underflow condition. So this is what stack. Next we'll go for the another data structure is queue data structure. Queue is double-ended. The one element is used to inserting the element. The other element is used to removing the element from the queue. The queue is when we are placing a queue, through the one end we are inserting the element that is placed in the next end position. Then the next element is the next. The another end is used for removing. So the first element which is inserted into the queue, that can be removed from the queue at first. So this reason queue is following the principle of first in first out method. So these are the linear data structure. In these two data structure, the user can modify according to the requirement of the user. He can insert and delete the data into the data structure. By the next session, we are going to discuss about non-linear data structure, that are trees and graphs. Thank you.